Okay, thank you, Michael. Yeah, so I think before Alex going through today's agenda, one big change, people join the call might already notice that. So in the future, we're going to have this hackmd.io webpage to list all our agendas. So previously the agenda is prepared by the presenter, but in future this agenda is open to everyone who will join this meeting. And if you have any items you are interested, whether it's the issue or whether it's some documentation related or feature request, you can add into the agenda. So we have a session called open discussion. So once you add it, and you can discuss with all the community maintainers and the community members. That's a change from previous meeting. And then I will give this to Alex to host the meeting.
All right, thanks.
Alex, do you want to share, or do you want me to share?
I can share in a little bit. I don't have anything right now.
Okay.
Actually, let me open up the project page. Can everyone see my screen?
I can see it.
Okay. 1 second. So welcome to the Harvard community meeting. So like Stephen said, we're going to run this in a little bit different format. It's going to be 30 minutes to an hour, depending on what we have. So today we have just a brief status update for Harvard 2.0, and then we'll give a quick preview of 2.1. So you can see the project board up here that has the 2.1 swim lane as well as 2.2. 2.0 commitments are the ones that are already either finished or very close to being finished. As things are being wrapped up and they're closed out, they get moved to the completed swim lane automatically. So this doesn't capture the entire payload, just some of what's remaining for 2.0. So the 2.0 release, we talked about in previous community meetings as well. It's not a big release in terms of feature payload, but it represents a big upgrade in the Harvard architecture. So this allows Harvard to be the first open source OCI capable registry, which means that you can push any OCI compliant artifacts to Harvard and be able to use that same feature set on Harvard UI for, like you could for container images and Helm charts. And then I think in the agenda, we have a list of the remaining bugs that we're triaging. So here, this is a list of the remaining bugs that we have for 2.0. So, we're doing quite a bit of testing for 2.0 because we have to test to make sure that everything that exists in Harvard today works for all the different artifacts that we're onboarding, like CNAPs, OPAs, manifest lists, etc. So if anyone's interested in helping us test Harvard against the new artifact types that you're interested in, or just testing some of the features, feel free to go through this list and add some comments, add some suggestions. As for the release date, the 2.0 is coming out end of this month. So we'll probably have an RC tagged, I think, a week from today, maybe the 15th or 16th. So that's all I have for 2.0. Do you have anything else to add, Stephen, before I go to 2.1?
Yeah, so I'll add a link in the hackmd.io page for our FC build. If anyone is interested to access the early build, so the whole feature functional very well. We want to collect some feedback from your usage. You can click this link and download it, install it.
Okay. It's right here. Yeah. And then we can take a look at the 2.1. So, here are some of the things that we're considering for 2.1. So the 2.0 comes out end of April, which means that 2.1 probably comes out 2 to 3 months after that. So the theme for 2.1 is going to be around better distribution, better content distribution. So Harbor working with P2P tools like Kraken and Alibaba Dragonfly, as well as what we're trying to do for proxy cache. So proxy cache is the ability for Harbor to act as a pull-through cache. And so it would front for a third-party registry. And you can pull images once to Harbor, and then geo distribute that to other Docker nodes to minimize pulls over the network or to utilize that caching ability. The other thing we're working on is what's called a non-blocking garbage collection. I'm not sure if it's here. No, it's the first one here. So this ticket is basically saying that it's an iteration on the current garbage collection. So the current garbage collection is online in the sense that it doesn't require locking the registry out. So users can still perform most of the actions on Harbor as you're running garbage collection, but with the exception of pushing and pulling images, deleting images, etc. So non-blocking would mean that you can still push images to the registry as you're running garbage collection. So it runs completely silent in the background. If you have any questions on the items that we're considering for the 2.1 sprint or the 2.1 feature release, feel free to add some comments on these tickets or raise other requirements that you feel are important or that you want to be worked on, and we'll try to reply as soon as possible.
Yeah, regarding the online garbage collection, there's a proposal already written by Yan and Vivi. Maybe Yan, you can add the pull request link from the proposal in the chat. So if people are interested, they can take a look.
So I added it this morning to the ticket. It's PR 133.
Okay, great.
If anyone's interested, here's the tech spec for non-blocking online GC or online non-blocking GC. So that's all I really had for the status update for 2.0 as well as 2.1. So with that, I'll hand it off to Steven for a demo of deploying a Harbor operator on a client cluster. So the operator, I believe there was either a demo or a discussion from on the previous community meeting. So it was something that OVH, a cloud provider in Europe, had worked on, and they had reached out to us to open source the operator under the Harbor repo. So we're nearing that stage of releasing the first beta version of the Harbor operator. So, Steven, I'll stop sharing my screen.
Yeah, I think the demo will be delivered by our member, ZiMing.
Okay.
ZiMing, I think it's your time to show the demo.
Okay. Let me share my screen. Okay, can you see my screen?
Yep.
Yep.
Okay. As you know, last week OVH team has showed some demo about how to install Harbor operator, but maybe some developers still not familiar with the operator. So here I'll show a step-by-step installation guide. Okay. First, I have prepared an environment, a Ubuntu system with 18.04. here. As you know, here I will show install Harbor operator on canned K8 cluster. The installation of canned is quite simple, and just download the canned binary, and you can also install the kube control like this. Then after you install the canned, here you will have the canned commander, and you can first create a cluster. And here I have a I have a script, and let me run it. Yeah, it may take 2 minutes. And as you see, in this configure, I will start three worker row because we want to show how to deploy a cluster, and because the Redis cluster need at least 3 workers. So here we start 3 workers. And here, because the canned cluster is just is not a production environment. It just use Docker to simulate like the cluster. So we need to make a node port. You use the node port to export the inner port. Okay, it is not right. Let's wait a moment. Yeah, when the clusters create, we will need to install some developer tools such as npm, yeah, and make and some Helm, and yeah, and some tools. We in Harbor operator we have a simple commander, the make dev tools, but this commander has some bugs, so we need to manually install some Helm and Go template first. I have already installed this. Okay. Okay, as you see, the cluster is started. Okay, as you see, there are 3 workers and 1 control plan. Okay, first I'll install the cert manager. We need to add some Helm repo here. I just copy them. And we'll create a namespace for the cert manager. And install the cert manager. Here I specify the version. It seems the latest version has some issue with the Harbor operator, so I specify the version. Okay. So let's wait a moment for the cert manager start. Okay, after the search manager start, let's create the Harbor operator system namespace. And then we can call the make deploy in the make file. This will install the Harbor operator system. Okay. As you can see, the Harbor operator system is deploying. Okay, it's running. Here we'll install some dependency software, such as the engine ingress and the database. In the production environment, user may have some load balance, so he may use some other ingress. We should use this command. The above commander has some issue, so the below commander has the same meaning. And we need to do a patch to make the canned export its node pod. As you see, the controller is creating. Okay, we can do this at the same time. This commander will install the database and Redis. Let's start it. This is not error. As you see, it will install 3 databases for Clear, Core, and Drop service, and 3 Redis service.
Yeah, for creating multiple databases and for creating multiple Redis instances, it's no issue. We will do improvements after some release.
Okay. Wait, it's done. Okay, it's almost done. The next part is actually deploying our Harbor. We will export the IP and set some environment, and also get the database secrets and Redis secrets. Okay.
Yeah, the database connection and the Redis connection, are wrapped into the Kubernetes secret. So the Harbor CRD will use the secret to get the related information.
Yeah, as you can see, the Harbor component is deploying now. At the same time, we can export the self-signed cert first. This will export the cert. Okay. All is running now. Let's try to log in. Okay, as you see, it is login success. Let's check the UI. Yeah, my network is a little slow. Okay, the username is admin and the password is the user ID here, ZiMing. Okay, as you see, there's nothing in the library yet. Let's push some image. Okay, as you see, the image is uploaded. And at last, if you need to clean the environment, you can just run can delete cluster. Okay. Any questions? My demo is stacked here.
This is a really cool demo, ZiMing. Thank you for showing that.
Okay, thanks. Okay, that's all.
Yeah, because the Kinda is a local cluster, so the purpose of demo showing this demo is if the user want to try the Harbor operator or use operator to deploy Harbor, use some local cluster like Kinda or Mini Cooper, they can have a try, but this is not recommended to use in the some production environment. As officially to support running operator and deploy Harbor use this operator on those local clusters, there may be some extra configuration steps. So maybe you see they're a little more complicated. But for some, if you have a formal Kubernetes class like load balancer is enabled, maybe some steps can ignore. Okay. So can you show the the generator manifest for deploying Harbor to the Kubernetes cluster?
You asked me?
Yeah.
Oh.
So yeah, your deploy is where the make command maybe we don't see actually the real manifest.
I just delete the
okay
the concept. Yeah.
Okay. Yeah, I think the guidelines we using to demo will be pushed to the repository. So if you want to try the operator with the Kinda environment, you can follow this guideline to go through.
All right. Yep. Thanks for that. That was a pretty good demo. So that was, operator for I think for those who didn't catch it, it's the Kind cluster Kubernetes Docker basically. So when we release this, we're going to upload it on the operatorhub.io as well. And so basically OVH started working on this when they were still consuming Harbor 1.10, I believe. And we had already started working on Harbor 2.0. So, merging this into Harbor at the moment, we're trying basically, we have to retrofit some of the early design to the new components I'm working on. For example, we as part of the 2.0 release, we're going to be replacing Claire with Aqua, an Aqua scanner called Trivi as the default scanner. So there's going to be some changes made to the OVH code, basically, introduce a new container for the Trivi adapter, We also have a feature that enables TLS between all the inner components of Harbor. So the first release is probably going to be. I don't think we have a time yet, but it's probably going to be a month or two out. So definitely watch for that, and yeah, it's something we're very excited about. So I think that's all we wanted to demo for today. That and the status update. We can give some time back to everyone, or we can, if you have any questions, feel free to ask.
One question: if we want to close a meeting and that time, actually we have a P2P demo.
Oh, we have a P2P. Oh, awesome! Sorry about that. Yeah, let's do that.
Okay. Okay. If no one has question to the operator, I can start the P2P demo. Can you see my screen now?
Yep.
Yeah, for P2P, we have set up a work group, to working on the related integration solution between Harbor and some P2P providers. So here is the list. Besides Harbor team members, we have members from Dragonfly teams. We have members from Uber Kraken team. So we also have our other maintainers and contributors to work in this group. So today I just want to share some of what we have done in this group. So for the P2P, it can accelerate the content distribution process, because one node can pull the pieces of the content from its neighbor nodes, so they do not need to to create heavy traffic to the central node. So I think it's very useful for distributing image for large runtime nodes. Okay, especially if there's a duplicate image distribution needed. They do not need to directly access the registry. So, to enable the P2P process, you need the first copy from the content management platform like image registry. So, if you do not push it to the P2P network, when the first pull happens, they need to connect to the upstream registry to do the first pulling. That may spend some time, maybe may cause P2P a little slower. So I think for some of the company or organization, they have some formal process to determine which images are ready to deploy to the runtime. So that means we can predict which image can be pushed to the P2P network in advance. So that's the preheat. We'll preheat the P2P network before the real requirements happen. So that's the we call it a preheat. Here is the overall architecture of the preheat. So far, we involve two P2P providers. One is the Dragonfly, another one is the Uber Kraken. Dragonfly is also a CNCF sandbox project, and we define some general interface between Harbor and those P2P providers. Then that's for each different P2P provider, they can implement a simple internal interface that's a driver. Then the overall preheater controller can talk to the to the different P2P providers. So I think the primary flow is very simple. If one image is determined to preheat, it can be the preheater controller can send a request to the related P2P provider. the provider will directly pull the image into their cache in advance. Okay, so all the action will be recorded as a history. So here is a preheat tracking. Okay, so far we only complete the work of supporting manual trigger the preheating process. Actually, for the overall or for the long-term plan, there will be a policy-based preheating. That means if some image match some criteria, the preheating process can be automatically happen. Like some label, some predefined label is added to the specified image, or the image is also scanned, it's also sent, then it will be, that means it's ready to start the preheat. So far, the policy part is not completed yet. So that's the overall process. Okay, so let's back to the live demo. Can you see the Harbor Web Console now?
Yes.
Yeah.
Okay, right. So yeah, this Harbor is deployed on the Google Cloud because we needed to talk to the P2P providers. They deploy into on the different infrastructure, so it's harder to connect internal. So I deploy a Harbor in the Google Cloud. So after you enable the after we introduce this feature, you can see there is a distribution. So this is the current design. For future, we'll move this under the administration because the P2P provider management is it's the privilege of the administrator. So the distribution is
Hey, Steven, you're breaking up a little bit. Alex, is he breaking up for you too?
It's pretty quiet right now. Like, can you hear us, Steven?
Yeah.
Okay. I wasn't sure if it was your network.
Yeah, Steven, you're breaking up.
Okay. How is it now? I'm lost?
A little bit choppy. I think you're...
Yeah, I can hear too.
How about now?
A little better.
Okay, can you see my mouse moving?
Yeah, try to keep going. Let's see how much you get out of it.
Okay, so now for the instances, we can add different P2P provider here. It's very similar like the scanner, but it's not out of tree. You do not need to to start a new container. It's wrapped in the it's supported by internal interface. So you can add a button to add a new P2P provider. For example, we add a Dragonfly to current. At present, we only support 2 Dragonfly and Kraken. Let me get the information. Dragonfly. We have set up Dragonfly. You just need to provide the endpoint of the Dragonfly's supernode and click OK. Waiting for a minute. Okay, so the Dragonfly provider is added to the list. At the same time, we can add the Kraken into the list.
By the way,
select the we just provide the Kraken. API endpoint. Click OK. So now you can see the two P2P providers added to the list. You can set the disable or enable of the specified P2P providers. If all the P2P providers you added are enabled, the preheat will, trigger on top of all the enabled P2P providers. So let me, so far, it's here. Okay, now it's two. I enable two of those providers. Now, as we have two P2P providers, now we can back to the image under the project, under the repository. We can find a little one, for example, base box. After that, you can see there is a preheat button. You can select to enable the preheat button. Now you can click this button to start the preheat process. Okay, it's a little slower. So you can see the preheat is successfully triggered. So far, we for the user experience, we missed something here. There is no status for user to check what's the progress of the preheating. So they need to back to the history. And from the history, we will record all the preheating process with the related states. You can see just what we did. Let me.
We should change the finish time so it doesn't
yeah.
play in that format.
You can see for the Kraken, we can see it's already done, and for the Dragonfly, you can see it's already done because it's a very small image, so it's very quickly. So what today's demo, I only show the operation of harbor side. I will not touch any operation in the P2P side, but how to check it, you can see the P2P preheating process is really heavy because there will be two access log generated. One is by the Dragonfly, one is by the Kraken. Kraken use username and password to put the image, and the Dragonfly use a token to put the different artifacts. So you can see there will be two access logs generated. That means the two P2P provider had received the preheating request and they have put the image into their cache. Okay, if you want to do a bigger one, maybe we can try the HA property. Okay, so it's a little slow. So let's back to the history. HA proxy, you can see HA proxy Kraken is done, and the Dragonfly is, oh, sorry, not this one. The information is a little fixed. Okay, Kraken is done. Let's see what happened to Dragonfly. Okay, I think there's something.
Hey, Steven, since we're out of time, you want to start wrapping it up as well, please?
Okay, I think that's me. I think it's something bug happened. I did not see the Dragonfly pull the, but for you think you can see it will happen. Okay. Yeah, as I mentioned, for all the enable P2P providers, the preheat will be triggered on top of the enable. If you don't want to trigger the preheating, you can directly disable the P2P provider. Okay. So that's the demo. Thank you.
Hey,
Any
Stephen,
question?
this is very powerful. I'll probably comment on the doc. I do have a lot of questions, but we're running a little bit out of time here. So I'll comment on the doc and add my comments. But this is amazing work. This is great progress. And thank you for helping drive this.
Sure. Thank you. Okay, that's all my part.
All right, everybody. I think that's it. Well, everybody have a great rest of your day or night, depending on what time zone you are. If you're in China, good night. If you're in Europe, enjoy the rest of your workday. And so for the US. Bye, everybody.
Bye.
Thank you for joining. Bye.